Hi again, everybody. This is Miss Raina here at C347 at MacArthur High School, your trusty physics teacher, coming to you today to talk about graphing. I want you to take out your guided notes paper entitled Graphing Motion Guided Notes, and let's follow along. So first we're going to look at constant velocity graphs. So the question becomes, what is the acceleration if the velocity is constant? If you answered 0, then you got it. So here is kind of like a little cartoon of a ball in motion. At time 0 it's here, at time 0.1 it's here, so on and so forth. And the question on your paper is, how can you tell it's not accelerating? So pause the video, take a moment, see if you can figure out how to answer that. And so how do we know it's not accelerating? Well, we've got to look at the relationship between all of these different variables. So at each increment of time, notice that the progress is only 20 centimeters at a time. The progress, in other words, is always constant. It never increases, it never decreases. So we know that the acceleration is 0, the velocity is constant. Here's a picture of the velocity versus time graph. And I want to remind you that I told you every time we look at a graph, I want you to look at the y-axis first so that you can see exactly what's being measured. And in this we can see the velocity is the same the whole time. Okay, so here's another kind of comparison of some constant speed graphs. In red we have velocity, we just saw that's constant. In black we have displacement, we saw that that increases over time because you're making some progress. And so the question from the very beginning was, if we have constant speed or constant velocity, then what's the acceleration? Well, we can see on the graph the whole time it's 0, and that's how you put it in graphical format. You draw just a straight line across the 0. All right, so just to reiterate, there's a picture of the displacement versus time graph. Nice upward slope. The velocity versus time graph is flat, but notice it's not at 0. It doesn't stay at the origin, and there's acceleration versus time. Sure enough, 0 acceleration the entire time. So what does this mean? The steeper the slope, again we look at the y-axis first, of the position versus time graph, the faster the object is moving. So if this slope were even steeper, screeching up like that, this velocity would be at a higher level. What's the equation for slope? Well, just like in math class, it's rise over run, and so that's how we calculate it. What about if we filled in the area under the velocity versus time graph? Then we'd have to get velocity times time, and if you have a look at your equation, that means distance traveled. So there we use the equation for area. Okay, so just to reiterate one more time, to get the slope, you need the change in y, or the rise, over the change in x over the run. In this case, it's distance divided by time. And you can even look at the units. That's going to be meters per second. So that'll give us velocity. The steeper the slope, the faster the object is moving. Just to reiterate again, area under the velocity curve will give us displacement. Okay, let's look at accelerated motion graphs next. So here again, we always make sure that we look at the y-axis first before we evaluate any graph. And now that we're looking at displacement, you can see that nice little curve means that every increment of time we're making more and more and more progress. Here you can see that means velocity is increasing, so now the acceleration is non-zero. Just to reiterate, one graph at a time, this curve means that we get more progress for every unit time, so velocity is actually going up. Because velocity is changing, now we do have a non-zero acceleration. And every time we look at a graph, I want you looking at that y-axis to see what's evaluated here. So what do the graphs mean exactly? Well, let's see. The slope of the velocity versus time graph is acceleration. And again, what's the equation for slope? It's rise over run, change in velocity over change in time. Again, if we do the area under the velocity versus time graph, we get the distance traveled. What's the equation for that area? 1/2 base times height. So 1/2 time times velocity. Okay, so just to reiterate again, there's the area under the curve, it's displacement. So what does deceleration mean? Well, in physics we use the same terms. Decelerated motion is accelerated motion, except now, instead of speeding up, we're slowing down. Now the parabola opens down like a frown. Now we're slowing down, we're not speeding up. Again, we're paying attention to the y-axis every time we look at a graph. So that was distance versus time. You can see that the velocity is slowing down when you look at the velocity versus time graph. And what happens to the acceleration? Well, it's not positive, it's not at zero. When you draw this, it needs to be below the zero line because when you're decelerating, your acceleration is negative. Okay, so let's look at some equations. Hopefully you remember this from your acceleration video, but this is one of what we call our three amigos. In order to calculate the distance, look, we're going by time squared. This is why we've got that parabola shape. Just like in algebra class, when you're looking at x squared, you've got the parabola shape to your graph. It opens up like a smile. What does that mean? Guess what? The acceleration is positive. It means that you are speeding up, not slowing down. Where is the initial velocity? Well, in order to figure out velocity here, we're looking at the slope of the line as we go up. So initially at the very start, the slope looks pretty flat. If the slope is flat, the velocity was 0, but see how it's getting steeper and steeper and steeper and steeper? That means it's getting faster and faster the whole time. Okay, here's a couple of reminders. You can pause the video here so that you have a chance to write each one of these things down, just filling in the blanks on your paper. Okay, now try this for an example. Here's car A and car B on your paper and decide which is moving faster. So if you decided car A is moving faster, then you got it. The steeper slope means that the object is traveling faster. So here's Mater, he's moving at a constant speed. Okay, and we need to ask ourselves the question, well, how far did he manage to travel in 10 seconds? This is asking us for distance, but they gave us a velocity graph, and it seems weird, but we can actually take advantage of this. To figure out displacement from a velocity graph, what do? We color this in and we figure out what is the area under that velocity curve. All we have to do is base times height. So 10 seconds times 1 meter per second gives us a distance of 10 meters. Okay, I'm going to leave it here for now, you guys, but pretend that there's Mater going off in free fall, and you got a couple of questions to ask yourself for a next time question. If he's in free fall, is he accelerating? Is he accelerating at the same rate the whole time? And would you say that his acceleration is positive or negative? Thanks for sticking with me through this long acceleration video. I'll see you guys tomorrow in class. Have a great day.